Hello chemists and welcome to today's episode of Bale's Chemistry. Today we are talking all about the uses of electrochemical cells. In the past couple of episodes we've looked at different ways chemical cells work, how we can work out the cell EMF and how we can use the electrode potentials to work out reactivity. Today we're actually going to get into how we use these electrochemical cells in real life. This is on the AQA Specification 1.11 Electrode Potentials and Electrochemical Cells and does appear on paper 1 of your A-level exams. So there are three types of cells that you need to know for your A-level exams. The first type of cell is a non-rechargeable cell. So a non-rechargeable cell is just like the AA batteries that you pick up at the supermarket. You might put them in your torch, you might put them in your remote control for your television or something like that. We then have the rechargeable batteries. Now these rechargeable batteries are much more common now. We see them in our mobile phones, we see them in our car batteries and other things that we can plug into the wall to recharge. And then we have the final cell, which is the fuel cell. Now, if you did triple science year 11, you will understand what a fuel cell is and you've seen it before. But if you haven't, don't worry, we're going to go into it in more detail later on. We'll start off by looking at those non-rechargeable batteries which you might buy from the supermarket. These use a non-reversible reaction, and when the reaction is complete, they no longer generate an electrical current and are thrown away. There are two common types of this battery, and they both involve reactions with zinc. The first uses ammonium chloride. This is a slightly older type of battery now and is less favoured because over time the ammonium chloride breaks down the battery casing and the battery leaks into your device. This is why it's not a good idea to leave those batteries in electronics for a long period of time. The second, slightly newer type of reaction involves the reaction between zinc and hydroxide ions and is often referred to as the alkali battery. The half equations for this cell are shown here. An AA battery has very similar components to a half cell that we've looked at already, having a carbon cathode, electrolyte solution and an anode. Rechargeable cells then are a little bit different. Rechargeable cells have reversible chemical reactions in them. It means that you can use an external source of electricity to reverse this chemical reaction. One of the common rechargeable cells that we use regularly is the one that's in our car. We draw a large amount of current to start the car and then we recharge the car battery while driving it over time. This type of battery is called a lead-acid battery and the oxidation and reduction reactions are shown on the screen now. You don't need to learn these, but it's useful to know what's going on. The lithium-ion battery is probably the one that you're most familiar with. You'll find it in your mobile phone and your laptop. The reactions at the positive electrode and the negative electrode are mentioned specifically in the AQA syllabus and are really important that you learn for your exams. In 2019, the Nobel Prize in Chemistry was given to John Goodenough, Stanley Whittingham and Akira Yoshino for their work on the lithium-ion battery. Fuel cells are the third type of cell we're going to look at on A-level chemistry. They're a little bit different to other cells. Unlike rechargeable cells, they are not charged up from electrical sources. Unlike unrechargeable cells, they don't hold all their reactants with them, but they are continually fed with hydrogen and oxygen. The electrolyte in the middle facilitates a redox reaction and electrons can flow around the circuit. There are many types of fuel cells, but for our A-level we're going to be familiar with the oxygen and hydrogen fuel cells. These can work in both alkali conditions and acid conditions. We'll start by looking at the alkali fuel cell. This is one of the first developed fuel cells and was widely used on the spacecraft of the US space program. This was due to the fact that not only do they produce electricity, but they also make drinkable water. At the anode, where the oxidation reaction happens, hydrogen gas is pumped into the system, where it reacts with the OH ions from the electrolyte and loses an electron and forms water. At the cathode, where the reduction takes place, the added oxygen gas reacts with water to form hydroxide ions, which can pass through an ion exchange membrane and move to the other side of the cell. This completes the overall chemical reaction where oxygen gas combines with hydrogen gas to form water. The electrolyte for this cell needs to be a soluble base, such as potassium hydroxide. And one key point to note from this is that the hydrogen gas is turned into water inside the alkali cell. So if we look at the oxygen-hydrogen fuel cell under acidic conditions, we'll notice the reactions are very similar but slightly different. The hydrogen is oxidized to form hydrogen ions. And then the oxygen is reduced by reaction with the hydrogen ions and electrons to form water. It gives exactly the same overall chemical reaction as we have with the alkali cell, but this time it's the oxygen which forms the water, not the hydrogen. The use of fuel cells has great potential in society. There are many great positives. Fuel cells don't produce harmful pollutants. The main product is water. The same water can actually also go on to produce the hydrogen, so it's always coming from a renewable source. They're also really convenient for things like cars and spacecraft that we've already looked at. However, there are a few problems with hydrogen fuel cells. First off, they can't replace large-scale electricity production. Hydrogen is difficult and dangerous to store and transport, and the mass production of hydrogen is really, really expensive. That's all for today. I hope that gives you a good idea of the 3 different cells that we need to be aware of for our A-level chemistry. If you haven't watched all our other videos on electrochemical cells, there's a link to the playlist on the screen right now. If you enjoyed this video today, hit the thumbs up. I really appreciate it when you do that. It lets me know that we've done a good job and that you've enjoyed learning from us. And if you haven't yet, hit subscribe to make sure you don't miss out on any of the new videos coming out to help you achieve your best.